to all. I am Wahida Amol, Assistant Professor in Mathematics from Content Development Center, Majlis Arts and Science College, Puramannur. Today we are going to discuss inverse trigonometric functions. Learning outcomes. To identify the inverse trigonometric functions. To find the derivative of inverse trigonometric functions. To solve problems related to inverse trigonometric functions. Before learning this topic, I am going to talk about functions and their inverse. There are 4 facts about functions and their inverse. First one, a function must be one-to-one in order to have inverse function. That is, any horizontal line intersect at most once. Second point, the graph of an inverse function is the reflection of the original function about the line y equals x. Third point, if is a point on the graph of the original function, then is a point on the graph of the inverse function xy, yx. Fourth point, the domain and range of function and its inverse are interchanged. That is, the domain of the function is the range of the inverse function and the range of the function is the domain of the inverse function. What is an inverse function? Let f be a function with domain D and range E. Then the inverse function f inverse is defined by f inverse of b equals a, where a can be chosen that f of a equals b. That is, if f of a equals b, then f inverse of b equals a. So, we can say that f inverse of f of x equals x or f of f inverse x equals x. What functions are invertible? In order for f inverse to be a function, there must be only one a in D corresponding to each b in E. Such function is called one-to-one. The graph of such function passes through the horizontal line test. That is, any horizontal line intersect the graph in exactly one point if at all. If f is continuous, f inverse is also continuous. Graphing the inverse function. If b equals f of a, then f inverse of b equals a. So, if AB is on the graph of f, then BA is on the graph of f inverse. That is, if this is the graph of the original function, suppose the blue line represents the graph of the original function and the green line represents the graph of the inverse function. If AB is a point on the graph, then BA is a point on the inverse function. That is, on the xy plane, the point BA is the reflection of the point AB about the line y equals x. Therefore, we can say that the graph of f inverse is the reflection of the graph of f in the line y equals x. Now, we learned a function is invertible if and only if it is one-to-one. Our topic is inverse trigonometric functions. What is trigonometric function? Trigonometric functions are real functions relating to the angle of a right angled triangle to the ratio of two sides' length. We know that trigonometric functions are periodic. Thus, the trigonometric function is not a one-to-one function. Then, how can we find an inverse of trigonometric functions? We know that the trigonometric function's domain is minus infinity, infinity. Thus, we want to find its inverse. So, we restricted the domain of trigonometric functions and thus we can find its inverse. Arcsine. Arcsine is the inverse of the sine function after restriction to closed interval minus pi by 2, pi by 2. Thus, we can find the inverse of sine function. We can find the graph of the sine function. We restricted the domain minus pi by 2 to pi by 2, we can find its inverse. Thus, the domain of arc sine or sine inverse is closed interval minus 1, 1, and the range of the arc sine is closed interval minus pi by 2, pi by 2. That is, the domain and the range of function and inverse functions are interchanged. Arccos. Arccos is the inverse of the cosine function after restriction to closed interval 0 pi. That is, we restricted the domain of cos to closed interval 0 pi. Here we can see the graph of the cos function, and when we restricted the closed interval 0 to pi, we can find the inverse function's graph. The domain of arccos is closed interval minus 1, 1, and the range of arccos is closed interval 0 pi. Thus, we can find all inverse trigonometric function, that is 6 inverse trigonometric function after restriction to the domain. 6 inverse trigonometric functions and their domain. First, y equals sine inverse x if and only if x equals sine y. Its domain is closed interval minus 1, 1. Y equals cos inverse x if and only if x equals cos y. Its domain is closed interval minus 1, 1. Y equals tan inverse x if and only if x equals tan y. Its domain is minus infinity, infinity. Y equals cosec inverse x if and only if x equals cosec y. Its domain is minus infinity 1 union 1 infinity. Y equals sec inverse x if and only if x equals sec y. Its domain is minus infinity 1 union 1 infinity. Y equals cot inverse x if and only if x equals cot y. Its domain is minus infinity, infinity. Next, we are going to find the derivative of inverse trigonometric functions. First, the derivative of arc sine or sine inverse x. For to find the derivative, first we let y equals arc sine x. So we know that x equals sine y. Differentiating both sides. Then cos y into dy by dx equals the derivative of x, 1, which implies dy by dx equals 1 by cos y. That is, what is y? Y equals arc sine x. That is, dy by dx equals 1 by cos of arc sine x. To find the cos of arc sine x, see the right angle triangle. Suppose this side length is x and the hypotenuse is 1. Thus, by the Pythagoras theorem, we can find this length is root of 1 minus x square. Thus, cos of arc sine x equals cos theta. The angle is the adjacent side by hypotenuse. That is root of 1 minus x square by 1. Cos of arc sine x equals root of 1 minus x square. We know that dy by dx equals 1 by cos of arc sine x. That is, d by dx of arc sine x equals 1 by root of 1 minus x square. Next, the derivative of arccos or cos inverse. We take y equals arccos, that is x equals cos y. Differentiating both sides. Cos y, the derivative is minus sin y into dy by dx, and the derivative of x equals 1, which implies dy by dx equals minus 1 by sin y. That is minus 1 by sin of arc cos x. We want to find sin of arc cos x. That is, from the right angle triangle, we can find sin of arc cos x equals root of 1 minus x square. That is opposite side by hypotenuse. Thus, d by dx of arc cos x equals minus 1 by root of 1 minus x square. The derivative of arctan or tan inverse x. So, let y equals arctanx. Thus, x equals tan y. Differentiating both sides. sec square y into dy by dx equals 1, which implies dy by dx equals 1 by sec square y. That is 1 by sec square y equals cos square of arctan x. That is cos square y equals arctan x. That is dy by dx equals cos square of arctan x. To find cos of arctan x, see the right angle triangle. Thus, we can find cos of arctan x equals 1 by root 1 plus x square. We know that dy by dx equals cos square arctan x. That is 1 by root of 1 plus x square whole square. That is 1 by 1 plus x square. Thus, we can find the derivative of arctan x equals 1 by 1 plus x square. Derivative of arc sec. First let y equals arc sec x. Thus, x equals sec y. Differentiating both sides. Then sec y tan y into dy by dx equals 1, which implies dy by dx equals 1 by sec y tan y. Here x equals sec y. Thus 1 by x into tan of y. That is tan of y equals arc sec x. Tan of arc sec x. That is dy by dx equals 1 by x into tan of arc sec x. We want to find tan of arc sec x. We see the right angle triangle and we can find tan of arc sec x, which is equal to root of x square minus 1 by 1. That is d by dx of arc sec x equals 1 by x into root of x square minus 1. Thus, we can find the derivative of all inverse trigonometric functions. Next, how to evaluate the inverse functions. Through examples, we can understand the evaluation of inverse functions. For example, evaluate sin inverse 1 by 2. Let y equals sin inverse 1 by 2. We know that sin y equals 1 by 2. Sin functions are restricted its domain for to find the inverse function. Thus, we can say that y must lie in the interval, closed interval minus pi by 2, pi by 2. Thus, the value of y equals pi by 6. Therefore, sin inverse 1 by 2 equals pi by 6. Next, example 2. Evaluate cos inverse minus root 3 by 2. For to find the value of cos inverse minus root 3 by 2, first let y equals cos inverse minus root 3 by 2. Then cos y equals minus root 3 by 2. We know that y must lie in the interval, closed interval 0 pi. Then the value of y equals 5 pi by 6. Therefore, cos inverse minus root 3 by 2 equals 5 pi by 6. What is the application of inverse trigonometric functions? We used inverse trigonometric functions in many areas. In engineering, physics, carpenters, aeronautics, navigations, all are used inverse trigonometric functions. For example, watching a helicopter take off. Our problem is a spectator standing 200 feet from a helicopter pad watches a helicopter take off. The helicopter rises vertically with a constant acceleration of 8 feet per second square and reaches a height of h of t equals 4t square after t seconds, where 0 less than or equal to t less than or equal to 10. The spectator perceives the helicopter to be rising at the greatest speed when d theta by dt is maximal. Determine the height of the helicopter at the moment the spectator perceives it to be rising at the greatest speed. That is, a person who was observing a helicopter take off, who standing 200 feet from helicopter pad, and the helicopter reaches at a height h of t equals 4t square. We want to find the height of the helicopter when the greatest speed. Thus, here says that the greatest speed is when d theta by dt is maximal. To solve this problem, draw a graph. Here, spectator is standing from a helicopter pad at a 200 feet distance. Helicopter reaches at a height of h of t equals 4t square. We want to find the height of the helicopter when the speed is greatest. Here says that the speed is greatest when d theta by dt is maximal. To find d theta by dt, first we want to find the angle theta. By the given data, we know that tan theta equals h of t by 200 feet. Thus, theta equals tan inverse of h of t by 200 feet. The angle of elevation of the spectator's line of sight at the time is theta of t equals tan inverse h of t by 200. That is tan inverse of h of t equals 4t square. 4t square by 200. That is tan inverse of t square by 50. Therefore, d theta by dt equals tan inverse of t square by 50. Derivative of tan inverse x equals 1 by 1 plus x square. That is 1 by 1 plus t square by 50 whole square into d by dt of t square by 50. That is 2t by 50. That is d theta by dt equals 2500 by 2500 plus t raised to 4 into 2t by 50. Therefore, d theta by dt equals 100t by 2500 plus t raised to 4. Next, to find when d theta by dt is maximal, compute d square theta by dt square. D square theta by dt square equals 2500 plus t raised to 4 100 minus 100t into 4t cube by 2500 plus t raised to 4 whole square, which is equal to 100 into 2500 minus 3 t raised to 4 by 2500 plus t raised to 4 whole square. Then setting d square theta by dt square equals 0 gives the value of t equals 2500 by 3 whole raised to 1 by 4 as the critical number of d theta by dt. By the first or second derivative test, this critical number gives the maximum for d theta by dt. That is, when d square theta by dt square equal to 0, d theta by dt equals maximum. That is, the value of t equals 2500 by 3 whole raised to 1 by 4. Thus, we can compute the height. Therefore, the height of the helicopter at this instant time is h of t equals h of 2500 by 3 whole raised to 1 by 4, which is 115.47 or approximately 115 feet. That is, the height is 115 feet. We can compute the height of the helicopter by using inverse trigonometric functions. Now we have learned the definition of inverse trigonometric functions, the properties of inverse trigonometric functions, the derivative of inverse trigonometric functions. The derivatives are for y equals arc sin x, y dash equals 1 by root 1 minus x square. For y equals arc cos x, y dash equals minus 1 by root 1 minus x square. For y equals arctan x, y dash equals 1 by 1 plus x square. For y equals arc cot x, y dash equals minus 1 by 1 plus x square. For y equals arc sec x, y dash equals 1 by x into root of x square minus 1. For y equals arc cosec x, y dash equals minus 1 by x into root of x square minus 1. And application. Through an example, we have learned how to apply inverse trigonometric functions to simplify our problems. Thank you.